Gravity is the force that attracts any object with mass. Gravity is the reason why things fall down when you drop them instead of up, and what makes matter clump together to form planets, moons, and stars. It is also the reason why moons orbit planets and planets orbit stars. This force is proportional to the product of the mass of the two objects that are attracting each other, and inversely proportional to the distance between the two objects. So, two massive objects will have a large force of attraction between each other, but if they are far apart from each other, then the gravitational force becomes drastically less. All objects near the surface of a planet accelerate at the same rate towards the center of the planet. However, the farther away from the surface of a planet an object is, the lower its acceleration is, and since the object accelerates at a slower rate, it also experiences a weaker gravitational force. In the case of a human that is farther from the surface of a planet, or in orbit, for example, this reduced force can have a tremendous impact on the functions of the human body.
How does gravity affect the human body? Our human bodies have evolved to function in the environment of Earth. This includes the force of gravity. Our bodies build up muscle to allow us to overcome the force of gravity on Earth. In a microgravity environment, the force of gravity is very weak and does not require a lot of energy to overcome. Living in a microgravity environment like space for a prolonged period of time causes muscle mass to decrease because many muscles are not being used. This can cause extreme injury and fatigue for astronauts. In microgravity, body fluids become redistributed away from the lower parts of the body. This often causes puffiness in the face and congestion. Because the heart does not have to work hard in space, it can lead to a deconditioning of heart function.
In microgravity environments, walking is no longer required because you get to float. Certain bones in your body, such as the hips, spine, and legs, therefore aren't used at all. This causes them to become weak because of bone breakage and a release in calcium throughout the body. The release of calcium doesn't only make bones weaker, but can cause the formation of kidney stones and bone fractures. People who are untreated for bone loss can lose between 1 and 1.5% of their bone mass in 1 year, while an astronaut can lose the same amount in 1 month while in space. Astronauts get a bit taller in space. On Earth, the discs between the vertebrae of the spinal column are slightly compressed due to gravity. In space, that compression is no longer present, causing the discs to expand. This results in a lengthening of the spine. The problem is that this will then cause back pain for astronauts once they are back on Earth.
So for the computer science aspect of this project, I created a program that calculates your weight on each of the planets and also on the moon and Pluto. So this is the user interface, this thing, and this is the source code for the user interface, and what that does, the source code basically just creates the picture and what it looks like to the person who's using it. And then this is the algorithm, which is the thing that actually calculates your weight on each of the planets. And then this is how it runs. So you enter your weight on Earth, say you're 120 pounds, you write 120, and then you click the convert button, and so you're 45.60 pounds on Mercury, 109.2 pounds on Venus, and so on and so on. And then to make it simple, I put a clear button and it clears everything so you can continue to use it. Say you're 200 pounds, convert. It just does your weight for 200 pounds. Yeah.